For this, we have a circuit, and we want to find the equivalent resistance, and then we're going to use the voltage to find the total current coming out of the circuit. So for this, we're going to assume that this is an amp meter, which measures the amps, and these are all the resistors. So we're going to redraw this in terms of parallel and series resistors. So series means that the input of one, the output of one resistor is the input of another, so these will be in series. And parallel means that two resistors have the same input and the same output. So you'll kind of see as we go along. So let's see here. I'm going to do this in terms of R. Start this way. We're going to have R1, and that's going to branch off into right here. So this is going to be R2 and R3, R2 and R3. I'm going to extend this one a little bit. So then this branches off again, and we have an R6 down here, and then we have an R4 and R5. And then they come together right here, and then it branches off one more time, and we have an R7 and an R8. And I'm looking at these in terms of their inputs and outputs. I want to make sure that the inputs on my drawing are the same as here. So like here for R4 and R5, R4's output goes straight to R5, and then R4 and R5 together have the same input and output as R6. So then we have, let's see here, we drew R7, R8, and then those come together, and they have the same output as the R2, 3 combination down there. So then this whole section right here, this input and that output is the same to R2 and R3, which is that input and that output. Okay. And then this loops back around to a 10 volt. I'll draw it as a battery. Whoop, there we go. We'll call it a 10 volt DC battery. Whoop, 10 volts. Okay. So now we're going to combine some of these. So let's see here. I'm going to leave R1 the same. Then it's going to branch off in R2, 3. So this will be, I'm going to call this R2, 3. And R2, 3, since they are in series, will just be R2 plus R3, which can be 100 plus 220, which will be 320 ohms. Then we come up to R4 and R5. I'm going to leave this in series. So this will be I'm going to call it 4-5. You could call it 45. But I'm going to call it 4-5 just to show that it's 4 and 5 together. So 330 plus 100 will be 430. Excellent. And then R6 is going to be the same. So I'll leave that as 390. Yes. And then we come together and we have R7, 8. So I'm going to call this R7, 8, which is going to be R7 in parallel with R8. So this is the first one in parallel that we've done. And so what we're going to do then is 1 over R7, 8 equals 1 over R7 plus 1 over R8. And I could just put this into a calculator and do it, but I'm going to be a little bit more algebraic and do a common denominator. So this will be R8 plus R7 over R7, R8 times R8 equals 1 over R7, 8. Take the reciprocal, and R7, 8, which is R7 and 8 combined, will be resistor 7 times resistor 8 all over resistor, I'll do 7 plus resistor 8, just to keep the same order. And so that's going to be 220 times 390 all over 220 plus 390. And we'll grab our calculator on. So we'll do 220 times 390. We get 85,800 divided by quantity 220 plus 390 Oh, make that a, there we go. And that gives us 140, I'm going to say it's going to be 140.7. I'll say 140.7. 140.7. Okay, so, and that equals R78. Get a different color, maybe red. All right, so now we have just R78 right here. And then that comes back in parallel and loops back again, okay? So now I'm going to simplify it again. So this time, actually I'm going to do a quick sidebar, and I'm just going to find R4, 5, 6. I'm going to combine all of those. And so for this one, they're in parallel. So we're going to follow the same formula we had here, where R4, 5, 6 is going to be R4, 5 times R6 all over R4, 5 plus R6. And one thing I forgot to mention earlier, when I found this 140.7, one thing to, when you add two resistors in parallel, one thing to check when you're doing it is to make sure that your equivalent resistance of two resistors in parallel is less than either of the original resistors. So 140 is less than 220 and 390, which is a good sign. Because if it's bigger, then you did something terribly wrong. Okay, back to R456. So R45 is 430. 430. R6 is just R6, and we know that is 390. All over 430 plus 390. Go back to the calculator. We'll do 430 times 390. And that gives us that number divided by quantity. 430 plus 390. Nope, that's a 6. Divide by the quantity. Yeah, looks reasonable. And we get 204.5. 204.5. And this was ohms. Okay. So now I'm going to redraw this again. So we have R1. And then we have R456 plus R78. And we have R23 combined. All right, so it's getting a little bit simpler, and there's a battery right there. So now we're going to do R4, 5, 6, 7, 8, which is just, since they're in series, we're just going to add the two together. So we're going to have 140.7 up here plus 204.5. Let's see, that'd probably be a 2 and a 1 and a 5 and a 4 and a 3. I'm going to say it's 345.2. 345.2 ohms. And I'm going to draw it again just to keep life simpler. I like to redraw it again and again. It just helps me make fewer mistakes. And when I do make mistakes, it's easier to backtrack to figure out what I did wrong. So now we're just down to 3 resistors, or equivalent resistors. So this is 2, 3. This is 4, 5, 6, 7, 8. This is 1. So now we're going to combine those two. So R2, 3, 7, 8 equals, and we're going to do the same thing we did over here, where we're going to multiply the two on top and then add them on the bottom. Same idea, common denominator. And so for the top here, it's going to be 345.2 times R23, which we decided was 320. 320 all over 345.2 times 320 plus, there we go, plus, equals, all right, go to the calculator. So now we're going to do 345.2 times 320. divided by quantity 345.2 plus 320. And we should get a number that's less than 345 and 320. We do. It's a 166. 166. I could do 0.1, but I'm just going to leave it as this. I've done enough rounding so far that trying to be too accurate is not going to be helpful. So this is R23 all the way up through 8. That's what those little dots mean. We draw it one more time, and we have an R1 and R. So I'm going to do this R1 and R2, 3, ... 7, 8. And so R1 ... 8. I know I'm just getting more and more abbreviated. Is going to be R1, which we know is 470. So it's going to be 470 plus 166. Since they are in series, and I'll just do plus 470, 636. 636 ohms. Okay, so the total equivalent resistance, I'll draw, I guess, I know I said it was the last one was the last time. This one will actually be the last time. There we go. Resistor, battery, 10 volts, and this is R1 ... 8, which is 636 ohms. And that's going to be the total equivalent resistance of the circuit. Now, they asked us to find the current, the total current, basically the current coming out of the battery. So it's going to be the total current right here. Whoop. And that's going to be done using Ohm's law. So V equals IR. Rearrange this. I equals voltage divided by resistance, which is going to be 10 divided by 636, which is probably something in milliamps. 1 divided by second answer. And we get 1.57 milliamps. So that is how we approach this problem. So the key here is we have a very complicated looking circuit, but these are all resistors in parallel or series. And so we can redraw the circuit creating equivalent resistors each time until we have one resistor which represents all of them together. And after that, we can then use Ohm's law to find the current that would basically be pulled or drawn through all this equivalent circuit right here. And we did that. We got 1.57 multiplied by 1,000 just to make sure we did the math right. Yep, 1.57 milliamps. So hope that helped. See you next time.